Page 67, finding the slope of a line. Notice we are doing this out of Ed Ready's order, so don't just go through the normal Ed Ready topics in the normal way, because we are going in a different order than they do. So slope, what's the slope? Well, it's used to describe the steepness and direction of a line. It is the rate of change between the y values and the x values. Notice I did not put those in alphabetical order. There's a reason for that. I'm comparing the y values to the x values. And it's represented by the letter m. I've heard m, it may come from French to climb, which sounds a little like mountain. Or it might be from some other reason. I've never quite gotten it verified. But whatever the case, we do use m. And m is just y2 minus y1 over x2 minus x1. Great, what does that even mean? So we're using subscripts here. We're labeling points. So if I have this point, that's x1, y1. Make sure your ones and your commas don't look the same. And maybe I have this point over here, x2, y2. The subscripts just tell me how to keep these x's apart, how to keep these y's apart. So if I wanted to find the slope between these, I'd just take this number, put it in here, this number, put it in here, and so on. You can also write that as change in y over change in x, delta, capital delta for change. Or you may remember this from another class, rise over run. Or vertical change over horizontal change. There are lots of ways to express the slope. And we'll use the slope in a number of ways as well. We have 4 types of slope. There's positive slope. The graph of a line with positive slope slants upward right. So it goes, as it goes from left to right, it goes up. Negative slope. It has negative slope. It slants downward right. So it looks like it's falling down. It could have 0 slope. Okay, if positive means it's going up and negative means it's going down, 0 means it's constant. It's the graph of a horizontal line. And finally, we can have undefined slope. So it's positive, negative, 0, or undefined. 0 is horizontal, undefined is vertical. Here's why. If I have a vertical line, my denominator is going to be the horizontal change. What's the horizontal change here? How far over do I go? Nothing. So I'm trying to divide by 0. That gives me something undefined. Okay, if we're finding the slope from 2 points, I'm going to use the formula from right up here. So y2 minus y1 over x2 minus x1. Now, which point is which? Honestly, it doesn't matter as long as you're consistent. So I'm going to call this x1, y1, this x2, y2. And I'll plug it in. So m equals -4 minus 3, y2 minus y1, over 0 minus 5. It's okay to have a 0 in the denominator because I'm still crunching numbers. -4 minus 3 is -7. 0 minus 5 is -5. So that turns into 7/5 because the negatives can cancel away. Slope is always a fraction. We're never going to use mixed numbers for slope. I would never turn this into 1 2/5. This slope is 7/5. We leave it alone. Go ahead ahead and try switching these. What happens if you make 5, 3 your x2, y2, and 0, 4 your x1, y1? What do you get? I'll give you, well, it's not even a hint, I'll tell you the answer. You should get the same answer. You should get the same answer. It doesn't matter whether you're looking at this as your first point and this as your second point, or vice versa. Go ahead and take a look at number 2. Then 3 and 4 are a little different, so we'll talk through those. I'm going to label this x1, y1, x2, y2. I'm going to plug it in. Feel free to go ahead of me if you'd like. 1 minus 1 is 0. Negative 3 minus negative 5. It's a little tricky. So I might rewrite this as negative 3 plus 5, right? Subtracting a negative is the same as adding a positive. Negative 3 plus 5 is going to give me 2. 0 divided by 2 is 0. Slope of 0. That's okay. Doesn't mean it's wrong. Just means that this is a horizontal line, like we saw up there. And now this one is also going to be a little weird because we have no horizontal change. So we'll be trying to divide by 0. And what do we get when that happens? What kind of slope? So these are examples 1 through 4. We'll also talk about how to find slope from a table or a graph. Let's go ahead and do this one. And I'm just going to pick 2 points. If this table is from a line, which all of the tables that are given to you are going to be, then all we have to do is pick any 2 points. So maybe I want to pick this one as my x1 and this one as my y1. I can do that. And I'm going to call this one x2 and this one y2. I'm not making any clever decision, I'm just picking some. Then I plug it in and see what I get. If you want to be sure, you can check it another way. Maybe let this be x1, y1. Let something else be x2, y2. You should get the same answer either way. Let's take a look at 7. Let's mark with the lettuce. Okay, so example 7. What I'm going to do is I'm going to find 2 lattice points, 2 points where the line crosses the at a grid point crossing. So you see right here and right here. If you saw different points, that's okay. These are just the 2 that I saw. I'm going to label my points. This is 5, 4, over and then up. This is -1, -4. I'll call this one x1, y1. This one x2, y2. Again, that choice was arbitrary. Plug it in. I have 4 minus -4 over 5 minus -1. 4 minus -4, that's 4 plus 4, so 8. 5 plus 1, 6. Now I said we leave the slope as a fraction, so I'm not going to turn this into a mixed number, but I can simplify it, and I usually do want to do that. So let's call this m equals 4/3. If you had happened to choose, for example, this lattice point here, you would have gotten, and one of these 2 blue points, you would have gotten 4/3 to begin with, and not had to simplify. So if you don't like simplifying, try to choose some points that are close together. If you don't really care, just pick whatever you happen to notice first. Let's take a look at 9. So 9, we've got a vertical line. Think about what the slope has to be, both because we know the answer and because there is no horizontal change. And let's go ahead and see one other way to do this. So let's take a look at 13. So I'm going to pick 2 points that are lattice points again. In this case, I see this one and this one. And I can write what those points are, x1, y1, x2, y2, calculate the slope like I did up for number 7. Or I can use the other definition of rise over run. So if I'm doing rise over run, I'm asking myself, how much do I have to go up from one point to the next? How much do I rise? So I rise 1, 2, 3, 4. Over run, I'm running 1, 2, 3, 4, 5, 6, 7, 8. Rise over run is 4 over 8, which is 1/2. So n is 1/2. I could have done that by calculating it. I can do it by just counting. Make sure when you count that you are counting with the correct sign. This was rising 4 because I was going up. If I had been falling, I would have put a negative. This is running 8 because I went to the right. If I'd been going left, I would have put a negative. Let's see one example of that real quick. Let's take a look at 14. I'm going to pick my lattice points. Again, I see this one and this one. My rise is going to be, let's start from here, or I can start from the other side, doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8. So I'm falling 8. That's negative. And then my run, I'm going over 1, 2, 4, 5. Written that way. Okay. And m is negative 8/5. Again, it's improper. I don't care. It's the slope. Okay. Or we can find the slope from an equation. Sometimes it's actually basically handed to us, which is nice. So what we're going to do is we're going to convert your formula into slope-intercept form, the y equals mx plus b, where m is the slope. Then all you have to do is identify your slope. Whatever comes in front of the x is your slope. So if we have 8x plus 4y equals 16, I'm going to say, well, is that slope-intercept form? Do I have y equals? No. So what can I do? Well, I can subtract 8x from both sides to get the y terms by themselves. Minus 8x minus 8x. That gives me 4y equals negative 8x plus 16. Okay, but I wanted y by itself. So let's divide everything by that coefficient in front. I'm going to get y equals negative 2x plus 4. Now I want the slope. It's just the negative 2. Slope is negative 2. And I want the y-intercept. This is always an ordered pair. It's always 0, comma something, and that something is just your b value. So 0, 4. What that means is that this line, when you graph it, it has a slope of negative 2, so I should have gone this way, and it's going to hit the y-axis at 0, comma 4. So if I were to graph it without looking at it very carefully, I know it hits around here and it goes down kind of like that. We'll see how to graph in better sketches later on. Okay, let's do one more together. How about number 3? Again, I have to convert that to a y equals something. So right now I have x by itself. I want the y by itself. I can do that a couple ways. I'm going to add 14 to both sides. So I have 4x plus 14 equals negative 7y. I'm going to switch the sides because I want y on the left. Negative 7y equals equals 4x plus 14. Divide by that -7. And I have y equals 4/7 x. I'm going to put my negative sign. I'm going to try to put my negative sign in front of the 4. It's not wrong to have it in front of the 7, but it's generally not helpful. Sometimes in graphing it is, and we'll see that later. But for now, we're just going to put -4/7 x minus 2. So what's your slope? And what's your y-intercept? On the y-intercept, remember that it's always an ordered pair, and it's always 0, something, because you're saying, where do I hit the axis? Well, I hit it when I don't go over at all. I just go up or down. Let's take a look at number 7 as well. So 7, let's look at number 6 actually. Number 6, I have y equals -4x. Well, where's my constant term? Well, I don't have it. So how do I figure out the y-intercept? Slope I can get, that's just -4. But the y-intercept, 0, something. What number am I adding to this? Nothing, right? And I could even write +0 if I wanted. So my y-intercept is the origin, 0, 0. So here I didn't have to convert to slope-intercept form exactly, but by adding a +0, that helped me. And sometimes if I have something like y equals, I don't think I have an example like it on this page, but y equals 3, I can rewrite that too. I could say y equals 0x plus 3. There's my slope, 0. So sometimes adding a 0x can be useful. Okay, once you finish that, go ahead and work through this page as well as the previous pages, and I'll meet you on page 70.